now I can walk around, even though normally I don't record it, but maybe it'll benefit some of those that aren't here. First off, I don't have a web connection, so I can't go to the website, but on the website, I put a link up to this section of the notes called the appendix on Matlab. It was always sitting there, I just didn't have a link to it. You can go into your web browser right now because you're logged in, presumably. And what I want you to do once you get logged in is start Matlab. Because I'm going to have you do a few interactive things all along the way during today's discussion. And then we're going to focus on, after we spend some time on going through the basics, and I'm not going to cover the entire set of notes, but then we'll jump over and we'll look at this worksheet that I've handed out to you, which will be helpful in practicing for some of the homework problems. I've already made my mind up that the homework that I thought could be due on Wednesday will be delayed until Friday, just because I know that we'll need the time. You'll want the time. I'm already giving it to you. But that doesn't mean you spend the weekend kicking back and watching, I guess, the last 2 football games before the Super Bowl and whatever else. I mean, you can do that, but if you need to be productive while you're watching games or whatever. I've got 2 teenage sons that are both 18 and seniors in high school, and one of them is studious about not studying in front of the TV. The other one, who likes sports a lot, probably does what some of you guys do, tries to do everything with the TV on, and, well, what does that do? Maybe it makes some of you work better, but I know for me it reduces my ability to get work done. So I have the iPod and the music, and if it's good background music, it actually lets you focus. But whatever, I got diverted there. Does everybody have Matlab up? You're going to have an environment that maybe looks like this, or chances are you've got an environment that has the panes, as in the window panes, set up somewhat differently. This happens to be the way I like to set my environment up, but Matlab is very flexible. So like if I wanted my figure panes docked over into here, along with my editor, code editor, I could do that, but my preference is to hold the mouse button down and drag over and set it up differently. I like to have my command window down here in the lower right. My editor, if I'm using it, is here, but if I'm not using the editor, I can slide that up and move it out of the way. Workspace, I keep over here, and the current folder that I'm pointing at, which right now I'm not pointing at any folder except the basic Matlab folder. But I'll explain some of that, and you'll figure some of that stuff out, too. How you set up your environment is kind of up to you. I think it will stay that way if you log into the same computer. It's part of your profile. If you buy a student version and run it on your notebook system, it'll definitely always be the way you last left it. In here, I don't know what will happen because you're going to move from computer to computer. But I'm picky like most engineers, and I have my favorite setup. You guys might be flexible. I think once you do a setup in Matlab, if you click one of these toolbars called desktop, I think you can restore the desktop to the default somewhere in here. You can also save your layout too. So you got a bunch of options out there. Maybe you've got so many options that it's just going to plain confuse you. I don't know. But now I'm going to flip back over to the notes for a little bit and just talk a little bit about Matlab. Matlab, as I said last week, stands for, or last Wednesday, stands for Matrix Laboratory. It's a tool that came into being in about the mid-'80s, I think. I started using it in the late '80s. So I've had more than 20 years using it. So now your excuse is going to be, well, my professor's been using it for 20 years, so I can't possibly master it in one semester, right? But, pardon me?
Can I use that?
I'm saying that you're going to try to use it, but you just go one step at a time. You learn some new techniques every time you sit down and use Matlab, and this class gives you a whole lot of practicing. You won't fall short of having opportunities to practice. And I will show you tricks when I go around, and I guess I should introduce Yulan over here. She's your lab teacher, for the lab sessions. Both her and I are in here every Friday. And next Friday, when you start actually going through the first lab on the lab schedule, there are sign-offs that you do as you work through the labs. And we come around and we sign you off as you make milestones in the lab. And what I make a habit of doing is, as you're demoing things to me, I try to show you tips and tricks. If I see you doing it one way, I'll say, consider this, try it your way. I mean, I want you to get up to speed as quickly as possible. So I'm not going to let you struggle needlessly if you're taking the long way. Just like everybody in here is kind of in a team, you'll share ideas on how to do certain things in Matlab, because one person will figure something out and another person will be like, how did you do that? And you might not even know what you did, and then you'll try to go backwards and figure out what you did to make something happen. And then maybe one of the two of us will come around and say, yeah, that was a smart thing that you just learned how to do. So you'll get up to speed, and it will be hopefully without a whole lot of pain and suffering. So the basic structure in MATLAB is a matrix, and that's a 2x2 data structure. MATLAB actually allows multidimensional matrices, thinking of slices of paper or sheets of paper, slices of bread stacked up. We're not going to go there at all in this class. So the most complicated structure that we use is a matrix. So it's just a 2x2 array. I mean, not a 2x2, it's just a two-dimensional array. But a two-dimensional array, as this points out right here, could specialize into what would be called a row vector, or it could specialize into the C, which would be called a column vector. And then a really special matrix is a 1x1 matrix, which is just a scalar. And that's the most familiar data type from C, right? You just have a single variable, an int or a float or something, and you just work with it. MATLAB is flexible, though. You can do things on the fly. Variables have to begin with a letter. You can use underscores in your variables, which I frequently do to spell out words and meaning. They can be any length, have to be unique to the first 19 characters. That was when I wrote these notes, which was quite a few years ago. Maybe they've changed that. So here's some simple examples of creating elements. I'm going to have an exercise here in a second that I'm just going to type out. But you can see that just by putting square brackets around 3.1415, I assign that value to the matrix A, just like that. If I say B is equal to 23, 35.3, I've just created a row vector that has two elements, and so on. If I put semicolons instead of commas, then I'm breaking it to make multiple rows. And whenever you terminate a line in a semicolon, like I've got over here, that suppresses MATLAB from relisting the variables. I'll just give a quick demo on what I mean by relisting. I probably should increase the font size here, so I'll go to Preferences, Command Window, I'm running the video here, so MATLAB's going to run slower. I'll change that up to about 14 and see what I think of that. Yeah. Okay, that's a little bit bigger font in there now. So as I was saying, if I had B equals 3, 4, 5, 6, and don't put a semicolon, it just lists the values of that array. But if I hit my up arrow, I can scroll back and redo the command. And if I put a semicolon in there instead, watch what do you think is going to happen from what I just said. I had a row vector initially. If I put a semicolon after each element, what should happen? Creates it into a column vector, just like that. Now, if I was really lazy, I would learn later that, oh, if I started with B like this, and I put a single tick like that, that's the matrix transpose operator, and it does the same thing. There's tons of little tricks like that. I'm just pointing out that You know, that's embedded in my brain. You'll get these things embedded in your brain too. You start slowly though. I don't want to overwhelm you, but I don't want to underwhelm you and think this is a lame tool. I want to let you know that it's very powerful. I mean, just the fact that I can hit the up arrow key and get back to a previous command is powerful, and I use that all the time because I'm lazy. If I want to remember the last time I typed the plot command, I just put in the single letter P, hit the up arrow key, and it's bringing me back to the last command I issued that had P as the starting. If I up arrow again, the previous time before that, and I just put Windows 7 on here 2 weeks ago, so I haven't run Matlab too much on here, so I don't have much of a command history, but it remembers your command history, so you can easily get back to entering a command and maybe making only a few changes in it. I don't know about you. I'm not a touch typist. I never took typing in school, and I'm lame because of that fact. So being able to scroll back and get old commands without having to retype everything all over again and just making a few minor tweaks, it's very powerful. Do you guys like typing? Okay, well then you can retype your commands, but being able to re-enter them is a really powerful thing that allows you to just keep working your problem out. And CLC stands for Clear Console. I just use that to clear up my console display. But the command history window over here is always showing me past commands. So if I have a command over here that I typed, and it also logs when I log in and out, so I know what I've been doing for this session, I can just click it, go Control-C, Control-V, and I can, get a command pasted back in again too. And I think you can even archive this command history, so when you left this workstation, you could archive it and put it in a file in your user account and have it back no matter where you go, if that was really something you wanted. In other words, if you had some commands that you didn't remember what they were, you could archive them and bring them back into the workspace the next time you came back. Okay, what are some other little nuances? These I'm going to skip over. I'll let you take a look at them. Line continuation. The colon operator. Not a person with cancer and needing surgery, but, sense of humor doesn't hurt either. The colon operator is very important to Matlab. It's one of its secret weapons, I guess, in making life easier. And as I said here, in my view, it's essential in becoming a Matlab expert. So learning a little bit about the colon operator is something we'll do right now, and that's what I'd like to have you try at your screens. And Yulan and I will kind of look to see if things are making sense. The colon operator is basically an iterator. So if I put 0:6, I'm telling Matlab to just step, starting at 0 up to 6 in integer steps. If I was to put, so as you can see, it echoed and created a vector from 0 to 6, element-wise. If I was to put 2 colons in there, and in between the colons put a parameter like 0.25, that says step from 0 to 2, but take the steps of 0.25. Does that make sense, that you can do that? I mean, you might say, that's so nice compared to writing a for loop in C and having to fill up a vector or an array with a for loop. This is just going to bang it out for me with one simple command. And I didn't even have to declare the size of my array or even tell Matlab that I was making an array versus a scalar. So why don't you, looking at this example here, why don't you just try a couple of these at your own command window and just see if you can get the hang of it. So if you got questions, raise your hand if something's not making sense to you, but I just want you to just try it and have it listed. Another thing that you can do after you've entered a few of these commands is you can go to the Workspace tab which is right over here, and you can see they're being created there. If you double-click, the workspace editor will open up like a spreadsheet, like an Excel.
Is there any way to get it to carry less precision when you're just working with, say, a quarter or something?
Yeah, that would be under... Question came up is, can I get less precision? Yes, you can. If you want to have the display precision less, you can go in here under your preferences, and you can go under... Let's see, which one is it? My brain is sort of failing me right now where it is. It's somewhere in here that I can set the precision. Right now, my brain isn't thinking, but it's under that setup. Usually I set it at a scientific precision. I don't know why I can't think where it's at right now. Okay, it's under command window. So you can set numeric format to short, long, short, E, general, and then you can have it be loose or compact notation. So under the command window settings, under preferences, is where you can set that up. Occasionally that'll be useful. Sometimes something will be tiny and it'll be suppressed and you want to see it. Other times, like your question was, you don't want to see it because it's annoying to see the extra digits out there.
Yeah, but you changed the value.
Is everybody getting things kind of like what I had here when you create the variables? Is everybody okay? Are you guys okay? Okay, I'm going to move on. So what else can the colon operator do? We've seen how it can create a row vector or a column vector if we were to transpose it. The colon operator can also be used to address back into the elements of the matrix. I mean, in C, you have a means of getting at the elements one by one with an index, right? Question? I'll look at what you're doing.
Percentage sign?
Oh, that? Okay. Good question. Question I was just asked is, what does it mean when I've got this stuff over here? Percent is the comment delimiter. So if I put a percent on a line all by itself or after a line of code in the command window, it just is for commenting only. It's ignored by the command environment. Just like when you write source code in Matlab, you will put comments in. It's kind of like the // or the /*, you know, how you did comments in C. It serves the same purpose. So I put that in here so that it was putting in comments on these command lines. So what else can we do with the colon operator? We can use it to address back out elements of a matrix. So here I've got a matrix that's a 3 by 3 that just contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 in 3 rows and 3 columns. I can then form a submatrix or get at elements of that matrix using the colon operator. So for example, here I take my variable A, which I've already created in the workspace, and let's just have me do that so I can have that handy over here. Oops. Hit too many keys with my fingers. So I'll just work with it right here in the command window. Hopefully you can see that. Maybe I'll sit down so I'm not blocking your view of the screen. So if I want to get back to elements of A, I can go, if I went A 1, 1, what do you think I'm going to get? Just the first element, right? But this first argument here is telling me the rows that I'm spanning. The second argument after the comma into the variable A, and you can see A is sitting over here in my workspace. And I think some of you notice if I double-click on A, it will open up in the workspace variable editor, which is like a spreadsheet over here, which I don't really care about right now, but it does exist. At any rate, if you guys want to listen? You're running interference to me. So if I want to span a certain number of rows, I can put in an index here. I could go like 1:2, and now I'm going to span the first 2 rows just scanning down the first column. See how that worked? If I put in colon all by itself, it'll just span all of the possible rows in column 1. You can just try that right now and just verify that. So just do the same entry that I did for matrix A and just verify how this colon operator works. Because it's very powerful. You'll be using it in the lab, and you'll get very proficient at it. Question?
So first we have to say it's a matrix because I'm just writing A equals that.
Yeah.
Do I have to say it's a matrix first?
No. As long as you type this in and hit enter like I did right here, it produced that output. It echoed the output because I didn't put the semicolon on there. But A was created.
Some of them are semicolons, right?
The semicolons are to break into different new rows. Remember, that's the delimiter to say start a new row.
So when you put a colon and a semicolon at the end, what does that do? I know when you don't put it in there, it expands and you can see it on your page.
Yeah.
It's just stored right here next to the other.
Yeah, it always is going to store it, but if you don't put it at the end, it just displays it back, echoes it back too.
I got you. All right.
You guys are doing good. I realize you're asking questions, which is good, but no one's throwing their arms up in the air saying, nothing is working. Either that or people are lying to me. Okay, good. This is not, what I'd call total rocket science. That's maybe a bad term because you should say electrical engineering is better than rocket science, right?
But we're required to study rocket science.
Okay. That's just an old saying, right? Rocket science is the hardest thing around, but I'd say electrical engineering ranks up there pretty good too. At any rate, so 1 to 2 says span all the first 2 rows and take just column 1. So can you extrapolate now from what I've just done and come up with some other things? I'm going to clear off my screen and try something else. What do you think will happen if I go 1, colon? I should get the first row and then all of the columns of the first row, right? And the first row was 1, 2, 3, and I just got it. 1, colon, yes. So suppose I want a submatrix out of here. Remember back, A is this 3 by 3. Suppose I'd like to get my hands on the submatrix that's in the lower right corner. What do you think that should be? You guys tell me. Remember, the first argument there spans the rows that I want. So which rows do I want? So I want 2 and 3, right? So I should go 2, 3. And which columns do I want? So I should go 2, 3. And if I hit enter, it'll echo back. There it is. And of course, I could have been assigning this to a new variable if I wanted to. I could have put B equals, and now I would have created a new variable B right on the fly. Matlab is lazy man's world. In C, you have to declare these variables. In Matlab, they just get created for you automatically. Yes, it's not the good coding practice of C, but we're into, modeling and simulation. We don't necessarily have to be as worried about things, declaring variables. You still have to be careful, and C has good, very, very, very good habits are formed by using C. Matlab allows you to form some bad habits. I acknowledge that fact, but if you come to respect what it's doing for you and the speed and efficiency, you just accept that. Matlab was also based on Fortran, and Fortran, which is what I learned, was a language where you didn't have to declare variables either, if I remember right. So there's some history involved here too. And they are not changing the rules just to satisfy new desires amongst programmers. So purists sometimes are frustrated with MATLAB's lack of forcing you to declare variables. Okay, I'm going to go back to the notes for a second or two now. So here's the transpose operator that I was talking about earlier, just the single tick mark. So that converts a row to a column, or it takes a matrix and interchanges all the rows for columns and so on, things you would have seen in basic linear algebra. If MATLAB can't do that stuff, it's definitely lame, because remember what the definition of MATLAB is, matrix laboratory. So it excels at doing matrix-type calculations. Okay, there's special constants defined in MATLAB. Lowercase pi is pi, and it has all the precision that you want, double precision. But if the display is set only to display short precision, it will just display like shown in this example. On your screen, if you type pi and hit enter, it'll probably have a lot more precision than that. Or maybe not. Okay, the default is the short precision. MATLAB also comes with I and j set to the square root of -1. So if you type I or j, you're not just going to see a scalar, you're going to see a 0 plus I1 or something like that. You just remember if that's what it does. So 0 plus 1 I. And j are the same thing. I don't think I talked about this yet, but electrical engineers use j over I just because we use I for current so much that we get confused. So j is our preference, but they're transparent with each other in MATLAB. Question?
Is I, J, K, we're using J for I, then what's J?
It's just for physicists and mathematicians, they can use I when they write MATLAB code, and we can use j. It's just defined twice. What do you mean by that, JJK? I'm confused.
Is I for the x coordinates, J for y vectors?
Oh, vectors. That hasn't been defined in MATLAB. I and j are just simply the square root of -1 is what they've been defined at. Square root of -1, as in complex arithmetic.
So can we not assign them as a variable?
Okay, excellent question. The question was, can we not assign I and j as a variable? Not true. If you go ahead and overwrite I, say I equals 5, MATLAB loses the fact that it's square root of -1 and now makes it 5. And if you later in your program rely on I for something to be the square root of -1, it's gone until you start MATLAB, reboot your MATLAB session. So be careful, because I use I regularly, but I don't use j in my programming kind of because of that reason. I don't want to destroy that property. But in actuality, a lot of times I don't even need I or j because it's still there. I mean, if I have a complex number, it will still pop up even though I may have overwritten I. This I that you see right in here is just part of the display notation. That's actually not the variable I. That's just part of the display. Okay, there's other special matrices. I'm not going to go into those. There's ways of writing programs that prompt you like you would in C. I'm not going to spend time on that. There's formatting. Remember printf in C, how you can do everything with that to format strings and things. It works the same way in MATLAB. It has the same string, and then you have characters, and you assign formats, and you use the % symbol to denote D or F, % F 4.2 or something like that. It works the same way as it does in C. Formatted strings is not something that we're really interested in right now, but that is part of Matlab's language. And here's a little discussion on that. We are interested in plotting, though. So Matlab has lots of plotting commands. The basic plotting command is just plot. So plot x, y. So I'll just run a quick example on that. And that's why I had my window slid over here, because I docked my figure windows up over in the corner over here. But if you were to create a vector x, and let's just create a vector that runs from 0 to 10. And I'm going to put the colon on here to suppress it. And now create a vector y, which is equal to, let's make it a function of x. So let's make it be x squared. How about that? Okay, so we'll plot a parabola. How are we going to do that? Well, I haven't made mention of this. You might think that that's going to give you x squared. But you'd be wrong, because MATLAB is a matrix language, so when you say square x, it's going to take a matrix to the power of 2, and that's not the same as each element of the matrix being squared. So MATLAB has a special notation when you mean something called pointwise. You have to put a dot in front of it. So x dot caret means raise each element or each point in x to the square, or the power of 2. So if I do that, I will get the intended result. And we'll see it when I do my plot right here. I'll plot x on the x-axis and y on the y-axis. And over here in my plot window, I have the parabola. If I would have tried to do y equals x without the point operator, it would give me an error message. And if I was listening with my headphones on, because my sound is suppressed right now because of the microphone, I'd hear a bong or a ding. MATLAB dings at you and shows red like that whenever you've made an error. You will get very annoyed at this in the beginning because you're learning MATLAB and it's dinging at you and showing this red error message. You will start, getting frustrated, like, what did I do wrong to make it, do this to me? It's just a syntax error. The reason why in this case it's giving the error, x is a row vector, right? Can I legally in matrix terms multiply one row vector times another row vector? They're not compatible shapes. So MATLAB is saying, it's beeping because it's saying you can't do that. But if I put the point in there, that means can I pointwise raise each element to the power of 2? Yes, I can. So that's why when you put the dot in there, it's just fine. And then the plot is just fine. It is the parabola, right? Some little neat things you can do on your plot. You can type grid to put a grid on there. You can type an X label, so X label, and then single ticks are how you delimit strings. So I could go X axis, it puts a label on there, scroll back up, change it to Y label, put Y-axis in there. What other label you think is going to be popular? How about a title? You named it, and you named it right. It's simply title. Title will be the title of your plot. Simple enough, right? Can we get fancier than that? Oh yes, a lot fancier. And by the way, if your plot window opened up in a single plot window isolated from all the rest and you get annoyed by it always disappearing behind your command window, what you have to do is, see the little arrow here I'm going to click on, I'll undock my plot window. So now my plot window floats. I personally don't like that because it'll go behind the screen and then I have to go find it again. So I click that little down arrow. It says dock figure. And you can drag around where the figure window docks. I could have it dock over in here. but that's where my command window is. My preference, again, is to have it sit over in there. Sound reasonable? Did you catch that? I was just moving the location of the plot window. And Matlab is so flexible, if I was to type figure again, it'll open up a new figure window, so I can have two figure windows up. I'll just dock that one with the other figure windows, and now I can have a whole collection of figure windows open. And I could type PL, scroll up, and I'll get my last instance of plot, and I could maybe change this to be X and minus Y. And I'll make sure I'm addressing figure window 2, hit enter. So now I've got two plot windows open. And Matlab is extreme. I can have them stacked vertically, horizontally, all kinds of different options on plot windows. Okay? Okay, what's something else I was going to show you? What else can you do here is you can hover over this thing called the data cursor, and then I can click, once I get the data cursor, I can click on my window, and it will display where I'm at. I can move to another spot. If I hold down the alternate key, I can have multiple cursors up. This will be useful when you start doing the experiment next week, or actually in the homework problem where you're plotting a cosine wave. You can put little tick marks on there and just take measurements. If I put the arrow key up here, I select the whole plot window, and then I could say double click on the caption over here. And if I double click on the caption and then right click, once the captions, I can change the color, I can change the font size, I could make it be 18 bold. Lots of different options there. Change line widths, I can click over a line, right click, change the width of the line. I don't know, it goes on and on and on. So it just giving you a little idea of all kinds of flexibility. And when you get ready to write a report, you can take this figure window and you can say edit, as long as I've got it selected here. And I can copy this and put it in a report, let's say. So I could copy this. I just got a Java error over here, which sometimes comes up because that's what runs this GUI. But if I was working in Word or something like that, which, see if I can find it on here since I don't use Word a whole lot. Microsoft Office is somewhere on here. Okay, yeah. There's lots of different ways of setting up how you copy plots depending upon the tool you're using, but I think this, I go Control V. Okay, I was selected the wrong item. All I got was my caption, so I haven't done any configuring on this, so I might not have it set up right. I have to have figures captured, copy figure, copy options was there. That's probably what I should have been messing around with. Okay, there we go. So this will become a routine that you'll be doing frequently when you're writing up labs or if you're inserting some Matlab analysis into a homework assignment, which I'll ask for frequently too. Because I'm always going for opportunities for you to work with Matlab and enhance your abilities to get it to do, help you solve homework problems or validate homework problems. Anybody have questions on some of the last little bit of details? Okay. To get it to dock, you have this little crooked arrow in here. It goes up or down. So if your figure window looks like this, which it should look like when it's on docked, that little down pointing crooked arrow will go dock it. And where it's going to dock it, I don't know, because the default is somewhere other than where I have it. But once it docks, then you can grab onto it, and you can see where it's going to end up. You can move it in different locations. And like I said, that's my favorite location, but that's been a habit that I've had for a very long time. Did you get it to work? Okay, good. Yeah, except it's the up arrow. It's like pull it up out of here, push it down in. And that holds true for all the tools within the environment, the editor and other things. These were some other things that I had from when we used to teach Matlab in the common freshman year curriculum, which we don't do anymore. So I'm just skipping over some of these basic operations. Here's, though, where the dot operator, this is something I've already showed you, but element by element operations on vectors and matrices is what we were just going through, and that's where that dot operator comes in. It's particularly important when you want to take one vector of the same length and divide it by another vector of the same length. If you want to divide point-wise each element by each element, you go dot multiply, or the example that we were doing was this scenario where we took each element of a vector A and raised it to the power B. Remember? That's how we got the squared. And I have examples of that in here. Operator precedence, this is pretty much like it is in C, so I don't need to spend time on that. A lot of different plotting types. We just looked at this basic plotting type. There's semi-log X and Y and log-log. What's something else I could have done while I'm at it? Replot that guy. The third argument here is where you get to put in a string. You can change the color to say R is red. Or if I want to change the line type, I can go say, let's see, that's not showing up on the screen. I can go colon, gives me a dashed line. All kinds of line type options. You could also just always make a solid line, click on the line, right click, and you can change the line style that way too. But colors, unless you're going to do your reports with the color printer, I wouldn't necessarily recommend doing this because they won't show up. There's also a command called legend, which allows you to automatically put in a legend. And you have to put that in as a string, so I could say legend y is equal to x squared. Now I have a legend, and I can click on it and move it around. And again, I'm getting some Java errors, and I'm not happy with that. I haven't used this version that much on Windows 7. I'm surprised it has errors. Has anybody had any errors like I did yet? Let's just try something a little bit extra that I'm going to get to in a second, but I'll do it right now. What if you want to overlay a second plot on top of this one? Matlab has a special function for overlaying called the hold command. So I would put a hold on that plot by typing hold, and then I can go ahead and run another plot. So let's just run another plot. Let's do x cubed this time. You see, it just laid right on top of it. So now if I wanted to update my legend, I could put a comma in here and put y is equal to x cubed. Yeah, I forgot that guy. So now my legend is fixed up. If I want to put a grid in there, I can type grid, and then I could go back and get my axes labels. This is where the command window memory is handy. What was the command for putting the X label on? It was X label. So I just type X, and then I scroll up, and it gets me the last time I call it, I can just bang it in there again, Y or YL for Y label. There it is again, no typing. And title was T, but I might put in TI to get me there faster. You see how quickly you can work in Matlab? Maybe you don't see why you want to work fast, but I do, because I need to get things done in a hurry sometimes and just go, gets done fast. I'm trying to show you some of my favorite tricks, but I know I could either bore you or put you to sleep, because it's like, well, you'll get overwhelmed. But you'll pick up tricks as you go, and you'll be rewarded by learning new things. There's all the line styles, and you can put markers on there. But I want to move to, though, to get us onto the homework. You can put subplots in. A lot of different functions in Matlab are built in, a huge number of functions. The functions I want to focus on are not these trig functions all by themselves, but I want to spend a little bit of time now until we're done here looking at complex variable stuff. Matlab supports it inherently. TI calculators, like I have the TI-89 or whatever calculator you have, supports it too. So what is a complex number? Thinking back a long time ago, an ordered pair of real numbers. And the way we plot complex numbers is, and we'll spend some more time reviewing this in class on Monday, we put the real part on what would normally be viewed as the x-axis. The imaginary part goes on the y-axis. Remember that from wherever. And where is that wherever? Just out of curiosity. High school, right? Have you done it here? Pardon me? Okay, college algebra, if that's where you had it. Has everybody had this? Because this was something that led to tears. The first time I taught this class, there was somebody that just never, ever had it. And I want to know right now, because I don't want you to fake it and then get really upset. Everybody's had it somewhere, sometime. It's maybe deep in your memory bank, and you got to get it into the foreground. And that's where the square root of -1 comes in. That's the imaginary axes, and this is the way we do it in EE. We have A plus JB, or Z is equal to X plus JY, whatever we want to view. So X is the real part, Y is the imaginary part, or A and B. These are the basic rules for add, subtract, multiply, and divide complex numbers in terms of the real part, real and imaginary parts. And then we have the polar representation, where that's the magnitude and that's the angle. We have the conjugate, which is flipping the sign on the imaginary part. Well, Matlab transparently supports all of these operators. I'm just going to jump over there. Matlab has conjugate, takes the real part with the real operator, imaginary part with the imaginary operator, and the angle with the angle operator. Now, angle is very powerful in Matlab, just like I have an angle function on my TI-89. The arctangent is how you normally think of getting the angle of a complex number, but what's wrong with the arctangent? What do you remember about being not so great about using the arctangent function? What's a peculiarity about using it? Does it work for all quadrants? Remember, if you have a real and imaginary axis here, this is 1, 2, 3, and 4. Which quadrants does the arctangent work properly in? How about 1 and 4? 1 and 3 has the problem that both arguments are negative, so the arctangent, if you try to put a number down in here, the arctangent will give you the angle up there because the minus signs cancel, right? Whereas if you try to put a number over into here, it ends up over in here because the arctangent is not smart enough to know which quantity is negative, the numerator or denominator. So the arctangent really only works properly in those two quadrants. So if you use that on your calculator, then you have to translate back to get it into quadrant 2 and 3 properly. You really know how to do that, but I can tell you right now, your calculator like this or a similar one, you can get away without remembering that because it takes care of that automatically. Just like, hold on, I'll take your question. There's another function called atan2, or the 4-quadrant arctangent, which is in C. Did you ever play with that in C, by the way? That takes 2 arguments, but an ordinary arctangent only takes 1 argument, and it doesn't then have knowledge of where the minus signs occur, so it has that ambiguity problem to get the angle in the right quadrant. I'm kind of dwelling on this some because if your calculator doesn't manage it for you, then you have to manage it, and if you make errors on a quiz or an exam, it's you're at fault. I mean, you have to know how to deal with it. There was a question. In the notes, I'm on page 32. Yep. Other than that, Matlab is very transparent. If I want to create complex numbers, it'll do it transparently. Like if I want to form a complex number Z1 that's 2 plus J4, I write it out like that. Remember, J has embedded in its, it's already predefined to be square root of minus 1. So if I want to add Z1 to Z2, I can do that. If I want to subtract, multiply, or divide, and that's, I did all 4 of those right down here and had them output in one vector. So let's just demonstrate that. Actually, this is about the breakover point. Since we're going to run out of time before too long, I'm going to switch off of these notes and I'm going to go to the worksheet that I handed out. The font is not big on this worksheet because it's just for your work. But as a first practice problem, very similar to set number 1, I'm asking you to get that complex number in polar form. In other words, convert it to magnitude and angle. And I gave the answer, worked on the TI calculator down below on my sheet. Eventually I'll put up all the solutions, but for right now I want you to be able to work it in Matlab and then work it on your calculator. So it's an exercise to do right now. And I'll kind of work through it. This is the Matlab code that I want you to type in to get Z. So we're going to put in Z is equal to minus 56 plus J18. But I have to put a multiply in there, plus J times 18. And so I'm asking you to give me the answer in polar form. And in polar form, that means I have to get the magnitude, which is the square root of the sum of the squares of the real and imaginary parts, right? But if we were to go back over here to the notes, which I took off the screen already, the notes would tell you that Matlab has a function called ABS, which gets you the magnitude of a complex number. So I would just do that, and there's the magnitude. Do you believe that? If you don't believe it, how can you check it? Well, you can go into the native calculation mode and just say, let's take square root, which is SQRT, of the quantity real part of Z squared plus the imaginary part of Z squared. That should be the same thing, right? The square root of the sum of the squares of the real and imaginary parts. You remember that formula? Same answer. I'm starting to get more dull looks, so I'm starting to get, your brain's starting to run down, I think. Question?
For
Yes. Yep. You're one step ahead of me, but I'm going to go there next. I was hoping that I could go there next, but if there's other questions, okay. So if I want to get the angle part, I could use the arctangent, but Matlab has the angle function built in. It takes and operates on a complex variable z. So there's the answer in radians. Suppose I wanted in degrees. What could I do? I could scroll back, and what would I have to multiply that by? If I wanted to convert radians to degrees, what would I do? Pi over, I want to go the opposite of that, 180 over pi, right? Yeah, 180 degrees divided by pi should convert radians to degrees. Making sense? And if I wanted to try to create a plot of that, I could have Matlab do that for me too. CLG clears the graph window, so I'll just clear that. CLF is figure. See, I used an obsolete command, so CLF is the new one. I forgot about that. At any rate, I've got that cleared. So Matlab will automatically plot a complex variable in terms of x and y parts. So if I just go plot z, there it is. But you're looking at that and you're saying, what is that I'm seeing? What do you think I'm seeing by just plotting that? Just the single point. So right in here in the middle is a single point, which if I was to make it have a marker on it that was an O or something, now I could see that it's there. But what I'd want to do, if I want to root this as a vector, I could augment that z with a 0, comma, space. And now I'd at least have an idea that it kind of looks like a vector, but it's kind of hard to visualize what I'm looking at because of the auto-scaling. 0, 0 is not in the middle of the plot. But there's commands for that. If I wanted to rearrange that, I could put in a command where I put in a string of variables, say minus 100, 100, minus 100, 100. These are the x min, x max, and y min, y max. So I'm going to create a viewport now in my plot that's going to say it's going to be minus 100 to 100 on the x and minus 100 to 100 on the y. And if I put the grid on that now it's starting to make a little bit more sense, right? I plotted a vector that's rooted at 0 and is hanging up over here. And we calculated that the angle was 162 degrees, which is sweeping around here over to here. You look at that and you say, that looks about right. Agreed? So out here on the tip of that is the point, and I could select that, and I could say, put in a marker that's a single dot, and there it is. Everybody okay so far? We're just about done because I know the time is going to be out pretty soon. But I want to do a few more things. I'll do a bunch more things if anybody wants to hang out. But if you're all needing to leave, I'll, Okay, the next thing I'd like to do on the worksheet side is go looking at, well, what did I do in the calculator? This is just the parallel. And I want you to practice these problems that way because you're going to be using your calculator on problems like these for the homework, but you can use Matlab to verify it. But next Friday, you'll have a quiz that will involve this sort of calculations, and you're going to be limited to using your calculator. So for this example, I took the screenshots off my calculator just so you could see how I did it on the TI-89 calculator. I entered in with parentheses a minus 56 plus, I took the I symbol on my keyboard and then put 18 in there. And then I went over to my math menu and went for the complex functions and picked ABS, just like Matlab would use ABS, and it returned that number right there. Actually, the first thing it returned is because of the algebra system, it said, I don't want to approximate this if I don't have to. I'm going to get as close as I can with in integer arithmetic. So it said 2 times the square root of 865, which I guess that's okay, but most of the time when we're doing this sort of calculation, we want numerical values with decimal points, so I just used another keyboard stroke on the keyboard to get it in decimal form. And you probably know how your calculator does that. The 89 does the algebra system, so it's a little bit fancier, but most calculators would just give you that 58.8218. And then I brought up off the math menu, complex submenu on the calculator, the angle function, and it first gave it to me in terms of an arctangent right here, but then when I did give it to me in decimal form, it gave me that number, which is the radians answer, just like Matlab gave me. The neat thing about some of these calculators is that you can just whip it out just like that. I didn't have to use any standalone trig functions. This calculator can do it that way, and I'm sure your calculator can do it the other way too. It's just if I would have had to resort to the arctangent, I would have had to compensate with pi in there one way or another. I would have had to make up for the fact that the quadrant it got placed into by the arctangent function was over here, so I'd have to push it back over into that quadrant to get it to be correct. So if I was doing it without the advanced capabilities of the calculator, I would probably draw a little picture of the real and imaginary axes and draw what I'm looking for, which is the minus 56 in the 18. Let the arctangent get me the number, which would be arctangent of 18 over 56. It would be an angle that would be some negative value, but then I'd know that to put it in the right quadrant, I have to add pi to it. And I'd make sure that it made sense to me. Otherwise, carelessness like that leads to errors, which leads to lack of points on the quiz or a reduction in points. I'd give you partial credit, but you wouldn't get full credit because you were careless in your use of the arctangent function. So if you're wondering how that is, you're going to have to go just refresh your memory on use of arctangent and the quadrants and so on. If you've got the powerful calculator, it's going to manage it for you. If you're going to borrow the powerful calculator for your quiz, make sure you practice with it beforehand. I'm not a TI salesman, so I'm not trying to sell a calculator to you right now, but you can think about it if that's, if you want to upgrade your technology or not. Okay, a second little example here is to go from polar to rectangular. So here I've got a complex number that has a magnitude of 80, and it's at 45 degrees. So MATLAB, I can enter the number in MATLAB. I have to use an e to the j entry for the angle. So angle theta is equivalent to e to the j theta as long as theta is in radians. That's just part of the representation for complex numbers. E to the j theta represents a complex number with a radius of 1 and an angle of theta. So in MATLAB, I can enter that in using the exp function, and then I've converted the degrees back into radians again with that pi times 1 over 180. And then MATLAB will just automatically display it in rectangular form. So if I was to go back here and go 80 times exp of j times, what was the angle again? 45 times pi over 180, it'll just automatically format the display. The TI-89 works identical to this. It has a little angle operator key and it has a little degrees key, so you can just enter it in directly, and as soon as you hit enter, you'll automatically put it in rectangular form. So it works pretty much like Matlab does. And of course, the real and imaginary parts are equal, and that makes sense, doesn't it? If we have something at an angle 45, the component in the y and the x are the same. So that's a good dummies check on that to see that you didn't make a typing error. Some other calculations are done in here just to practice on, and I'm going to let you take a look at those. There's a subtraction. When you subtract numbers in complex variables, if you do it by hand, you need to get them in rectangular form. But again, if you were doing this on the calculator, it would be transparent. So you might want to just work that one a couple different ways on your calculator. In Matlab, no problem. I mean, Matlab just, if I wanted to go back up to this calculation here and I wanted to take my original number z and add it onto it, or subtract it, Matlab just plows right through it and just does the complex arithmetic. Plotting, we've already talked about that. One of the things I'd like to just spend a couple of minutes on is user-defined functions in Matlab. This is something that is very powerful, and this is just like what when you wrote functions in C. Remember writing functions in C? What was the main benefit of writing a function in C? You could reuse it, was what the comment was. Anybody else have a good reason why you'd write a function? Okay. Let's just write a simple function in Matlab, get you started on it. I've got a skeleton there in the handout, but I'm just going to start from scratch. My editor window is right here. So how do I get a file to edit? Well, I'm sitting up here. I have to go to the editor window as opposed to the variable editor, which I'll just kill. So I'm hitting here. I would click this little white sheet of paper that says new M file. And so now I've got a source code file opened up, and I would go save this. So I'm going to go save as I'll just call it my function. It will go into your workspace, and I'm not sure where your workspace is pointing. It might be pointing at your home directory on your UFP account, or it might be somewhere on the local computer. I'm not really sure where. If you want to know where your current folder is, you go to the current folder menu, and mine tells me where I'm at. I'm in a folder off my documents folder on my notebook here called Matlab. At any rate, I've got that function. If I want to create a function in Matlab, I have to start the file with the words function, and then I give it a name, and the name has to be the same, or should be the same as I've given the file itself. My function, I'm going to put x in, and I want to go back to the beginning. I want this function to return y. So this is equivalent to what in C you call the function prototype. Remember that from C? Or is that the term they use, prototype still? Somebody said yeah, is that right? Okay. But notice how lazy Matlab is. I didn't have to declare that the return variable was a float or a short or anything. I'm just saying what goes in and what comes out. So we could put another variable in here. Let's call it G for gain as another parameter. Then I can put some comment lines in here. And generally, I just put as my first line of comment code, I'm just going to put in what that function is. I'm going to save it. Any lines that follow the function declaration with the % sign for commenting will get echoed back if I sit down here and I type help my function, whatever I put up there right underneath that function declaration comes echoing back at me. So it's very useful to have that as online documentation, so you can write code that's self-documenting. That's your help that will help you remember what this function does, what variables it took in. You can explain what all the inputs and all the outputs mean. So now to complete the function, all we have to do is say y equals something. So let's say y is equal to parameter g times cosine of x plus, I don't know, anything I want to throw in there. I can just leave it at that if I want to. Put a semicolon on there so it doesn't echo. Hit Control S to save. Let's just do something else. Let's just say g is equal to g plus 10. So I'll offset g after it comes into my function with a 10. So now I'm going to go down here and create an x vector that sweeps from 0 to 2 times pi. But I'm going to sweep it in smaller steps, so I'm going to go in steps of pi over 200. Now I'll call my function, and I'll put in the x-axes that I just created with the line up above, and let's just let my second variable g equal, I don't know, 5, let's say. Okay? The next thing I'm going to show you, before I hit enter, I'm going to quickly debug my function just to let you know that you can check it out and see how it's working. See these little dash marks? I can click on those and I can create a breakpoint. So now when I call the function down here, it's going to stop at that breakpoint. I can go inside my function and I can hover over the variables that got passed into it. There's my vector x that got passed in. There's my g that got passed in. I can go up to my debug window and I can say, let's take a step. And now I can see that g is no longer 10, it's now 15 because I just executed that line of code. If I step one more time, I'll get the down arrow because that means I've now executed my last line of code. And if I was to hit this again, I would be exiting the function, and I just listed off all the arguments in my function because I never put a semicolon in there. Turn the debugger off like that. Do the same thing. I can go ahead and plot that, so I could go ahead and plot x comma y. And back over here in my figure window, there's the function that I just created. I could go on this, but I just wanted to show you very quickly how easy it is to encapsulate a mathematical idea that you want to model, give you a quick look at how the debugger works. And the neat thing about doing things with functions is something that somebody didn't mention is all of the variables that are used as temporary variables inside this function are not left out in your workspace. So you can kind of keep things neat and tidy. Temporary variables are inside the function, and what was that called in C? Remember that? There's a term for that. Variables declared inside a function have, or there's a terminology, local scope or scoping of variables. They don't get conflicted with variables outside because they're separate. They have local scope. Question? In the editor, you mean? That's probably a setup configuration under Preferences, Editor, and Debugger. Show line numbers. See that? It's under Editor, Debugger, and then open that up and you should see Display, and then you have the option of showing line numbers. Yeah? Pardon me?
How do you get to your editor here? I know how you get to your workspace command. We don't know that.
Okay. Click that guy to open up a new document. Your editor window should pop up somewhere on the screen. I'm not sure where it's. Yeah, yours. Yeah, the editor window and the default setup is not docked anywhere, so you had to create a blank document and then you can dock it. You can click that guy, and then you can dock it somewhere on your screen. Hit the down arrow, I guess. You got 2 editor windows open. Yeah.
I know. I'll figure this.
Yeah.
It's pretty easy, but you see how it's 7/8? How do you actually make that to decimal? I know it's like more of a user calculator, like you actually know how to do it yourself, but I mean, it's like a menu decimal configuration in your calculator.
Yeah, I remember that, but that should work. What I do on mine, and yours is just a newer model, and I think the keys work the same. If I was doing arctangent,
Oh, hit the green key.
yeah, the green key first,
Hit enter.
then it does decimals.
Oh.
I didn't know how to explain that,
Also
but
go to,
okay.
So thanks for staying over a little too. That's good.
No, you want to be
Allow
down
to go
here.
out really quick.
Display.
To file and then preferences. File
Show-
preferences.
Yeah, line numbers in the editor, but I don't think you ever got an editor window up because you would have had to go like this. Now you've got an editor window, and then you could dock this editor window, and it'll be docked right up in here like I was doing.
So there's my number.
Yeah, exactly, and that was where I typed my function file right into the editor, and then I saved it and did all the other stuff.
But you don't have to do it there, right? You can do it in the regular Mac.
No, the command window is just for instantaneous stuff. If you want to document stuff and have a reusable function, you have to actually type it into the source code editor.
Okay.
And I forgot that's the way it was set up, so I didn't lead you down that path.
And we can only debug in the editor? We can
Correct.
only debug in
Yes,
this
that's
thing?
right, yeah.
And then
But when you're
how do I
stopped in the
get this out?
debugger, you can go down here and you can, I don't know, there's a lot of neat stuff you can do.
How can I get out of this whole thing? Because when I close it and I open it, it's still all there.
When you close MATLAB,
Yeah, when I close it.
well, it's just remembering your workspace.
And then if I open it, then it's all still there. Maybe it's not. Maybe
I think the default is probably set up to remember your workspace.
here it's all here.
Yeah, that's your command history and everything. That's actually to your advantage, because that way, if you owned this computer, you'd come back for another session and it'd remember all those command histories and everything that you had last typed. That's very powerful, because when you write complicated code, you have these complicated command line entries, and you don't remember what you typed. It's really nice to be able to just scroll back and have it all right there again, because then you can sit down and get back to work quickly. That's not due at all. I'm going to put solutions out probably Monday after class. That's just practice that I wanted to inspire you to practice at. Yeah, and then when you work the first homework assignment, it'll help you on that. And there'll be a quiz over calculations using your calculator next Friday. I'm going to stop my video here.
I got a laptop. I want to install Matlab actually download a weak file. Do you actually have to have a login to actually use that?
I'll ask him.
You're talking about MATLAB?